So now that we've talked about all these different ways of computing limits, where we're computing limits that wind up equaling infinity and computing limits as x approaches plus or minus infinity, let's put all that together and see how that all ties in with asymptotes. So, in this problem here, we're going to find all the asymptotes of the function. To do this, we have to decide, do we want to start with vertical or horizontal? Either one's fine. So let's start with vertical. Because this is the trickier one, usually. Let's get this out of the way. To do this, we need to factor this equation. We need to factor the top and the bottom of this function here. Now, the top of this function won't factor. Right? You can check it with the quadratic formula. You're going to get something under the radical. That's not going to work out too nicely. So we're going to leave this up here as is. Right? On the bottom, this does factor as x plus 3, x minus 1. So again, normally what you would try and do here is factor the top and the bottom and do any cancellations that you can. Because any terms that cancel out, they're not going to be contributing to vertical asymptote. It's only when you have limits that go to plus or minus infinity. So, now if we look at this here, we see two numbers on the bottom where the denominator would be 0. We have x equals negative 3 and x equals 1. So what we need to do is check the limits here, right? Now remember from earlier, to figure out if there's a vertical or horizontal asymptote here, all we need to do is see, does the limit from the left equal infinity or negative infinity? Or does the limit from the right? We don't have to check the two-sided limit, which is kind of nice to know. So it's sort of pick which one you like better. Which one you'd rather do here. Of course, you can do the two-sided limit. So let's say here I'm going to pick limit from the left. We'll do from the left for the first one and from the right for the second one. Right. The limit as x approaches negative 3 from the left of this. Okay. So 3 minus 1. So remember what we have to go through for this. We need to figure out, is the top positive or negative? Is the bottom positive or negative? Right? Since we're coming from the left, we're looking here at numbers x less than negative 3, but we also want to stay close to negative 3, right? We don't want to go like way far down to like minus 100 or something, right? You want to stay pretty close, right? So if we stay pretty close, x plus 3, if we plug in a number less than negative 3, this is negative, right? This factor. This second factor is also going to be negative, right? So since both factors on the bottom are negative, the entire denominator is going to be positive, right? Because a negative times a negative is positive. All right. How do we figure out what the top is going to be? Right? Well, if we could factor the top, we could do the exact same thing we did on the bottom. But here we can't factor the top. What we can do is actually just plug in negative 3. Right? Because the bottom we can't do it, but if we can plug it into the top, it's going to stay the same when you're really close to negative 3. It's not going to change sign that quickly. So let's just plug in negative 3 here. And we'd get 2 times 9 plus 4 times 3 plus 1 So that's 18 minus 12 plus 1. And this is greater than 0. So the top is also positive. Right? So since the top and the bottom are positive, what this means is that the limit itself, let's see if I can just extract the limit here. Get it? So this limit that we're trying to compute, the top is positive, the bottom is positive. We know that if we tried to just plug in -3, we'd get 7 over 0. So it's got to be one of the infinities, and it must be positive. Okay. So that means x equals -3 is a vertical asymptote. Now let's do it for the other number. X equals 1. We have to do it here too. This one, like I said, we can do it from the limit from the left or the right. Just for the heck of it, let's do it from the right this time. Alright, so limit as x goes to 1 from the right. Let's use the magic of copy and paste to not rewrite this. So again, we're going to do the exact same thing. We're going to plug in numbers. Here, we're looking at x bigger than 1, but still close to 1. So if we plug in a number bigger than 1 here, this is going to be positive. So is this one. Right? Again, because they're positive numbers. Now again, if we did the limit from the left, this one would be positive, but this one would be negative. Okay? Now we look at the top. Again, we can just plug it right into the top. So we have 2 times 1 plus 4 times 1 plus 1. And this number is positive. So the whole numerator is positive. The whole denominator is positive. There's just positive all over the place here. And so this limit itself must also be positive. So let's once again use the magic of copy and paste. And we find out that, okay, this is infinity. And again, it doesn't matter if it's infinity or minus infinity. Either one, again, tells us that x equals 1 is a vertical asymptote. Right? Either way. Okay, so now that we've done a couple examples of that, let's do that's all the vertical asymptotes. Now let's do the horizontal asymptote. How do we do that? Well, the horizontal ones will actually be a lot easier if we use the unfactored version. Okay. So let's duplicate this, bring it down here. All right. So let's go for the horizontal asymptotes now. All right. So what do we want to do here? Well, we need to compute 2 limits. Right, we need 2 limits. We need the limit. We need to compute the limit as x goes to infinity, and the limit as x goes to minus infinity. And these can be 2 different things. Okay? In this particular case, oh sorry, I didn't write negative infinity. In this particular case, they're not going to be different. And that's because the highest powers are both even here. But, wait, actually, even if they're odd, they'd be the same. So, in this case, okay, so they're both going to be the same here. It is possible, though, to have 2 horizontal asymptotes. right? So try and imagine what that might look like. A function with two horizontal asymptotes, two different horizontal asymptotes. See if you can figure that out. Anyway, so we need to compute these limits here. So let's look at this expression right here. Right? Duplicate that. We're going to do the same trick for both limits, so let's manipulate this first, and then we'll just compute our limits from there. So do you remember how we have to do this? So we look at the highest power on the bottom, which is 2. So we multiply the top and the bottom by 1 over x squared. Right? If we do that, then the top becomes 1 plus 4 over x plus 1 over x squared. The bottom becomes 1 plus 2 over x minus 3 over x squared. Okay? So that means we want to compute the limit as x goes to positive infinity of this thing. Okay. When we do that, we're going to get 1 plus 0 over 1 plus 0 minus 0. And so this is 1. Right? And we're going to do this again, but this time going to, we'll just move this down here, going to negative infinity. All right, but again, if you think about how this is working out, you know, all of these still go to 0, and then we just have 1s left over. So 1 plus 0 plus 0, or 1 plus 0 minus 0, that's 1 again. Right? So again, I want to reiterate that it is possible for these to be different answers, but in this case, they're not. Okay? So in this case, we'd say y equals 1 is a horizontal asymptote. All right. So let me just emphasize here, vertical asymptotes are equations like x equals, right? Because those are vertical lines. And those come from where the denominator's equal to 0, but the top isn't. Horizontal asymptotes, on the other hand, you have to take the limit to infinity and minus infinity. And those come in the form y equals whatever the values of these two limits are. Right, so just summarizing all this here, the vertical asymptotes are x equals negative 3 and 1. Right? Let me double check that. Yep, negative 3 and 1. The horizontal asymptote is y equals 1. And that's it. So hopefully that helps you kind of understand how to compute these things, how we go about this, and sort of what this is all about. Take care.